What? What? Oh, hi. Yeah. Oh, I guess we're there. Hi. Today on Secure Digital Life, I was just kidding. Today on Secure Digital Life, we're going to talk about creating virtual labs for fun and profit because you asked. Well, maybe not so much on the profit, but we're going to talk about how to get started building virtual labs so you can break things and experiment without ending up in federal prison. And we all know what goes on there. Or even worse, hiding in an Ecuadorian embassy without internet. So stick around and we're going to talk about it.
This is a Security Weekly production.
Welcome to Secure Digital Life. If your users are going to keep putting risky stuff on your machine, you're screwed. So Top can help us understand the complexity of blockchain.
I was reading through the show notes, man, and oof.
In binary, it would be 001. Who cares? But it's probably not significant anyway. Be like you're looking out through the HAL dot, like,
oh,
hey, Dave.
It's like Sims, but with,
It would be like Sims.
Instead of AI, it's only.
Roger Williams University is a premier destination for cybersecurity, offering in-person and online classes designed and taught in collaboration with industry experts. Using virtual environments that simulate real-world systems, you'll solve complex cyber issues and analyze cyber threats to prepare you for in-demand jobs in this rapidly growing field. Whether you're just starting out or want to advance in the cyber profession, RWU offers degrees and coursework at all levels. Learn more at rwu.edu/cyber. B-Sides Orlando Shootout, full sale, 7 April. That's coming right up. That's like this weekend. So you should definitely check that out if you're in Orlando. If you've never been to B-Sides, you really should get out to one. They have them all over the place. They have them probably one near you somewhere. Students get in free if you have your ID, labs, speakers, challenges, all that kind of stuff. What's not to like? I'll be at RSA in a couple of weeks. So on the 18th of April, be sure and come by. I think I'm going to be at the NetSparker booth doing the show. I'm going to be there all around. So I'll be there on Monday and Tuesday. So if you want to come check it out, my presentation's on Wednesday morning at some early, really awful hour, but at least on the West Coast. So it's not such a big deal. And so you should come check that out. It's at the Marriott Marquis. And I think they have the whole downtown. There's like 50,000 people there. So if you're coming to RSA, be sure and come say hi. So that we can, you can actually see I'm a living person and I'm not fake. Hi, Russ.
Hi, Doug. I thought you were AI. I wasn't sure,
I wish I was AI. I'm waiting for the cyborg infusion of things so that I can become. I'm ready to plug in and get tuned up and all that kind of stuff. So I'd be restored and join the some kind of a futuristic that Übermenschen. Was that Nietzsche? Is that who talk about that?
Sure.
Well, you're the post-humanist guy, so you're supposed to know all this
that's
stuff.
post-humanism, not existentialism.
Oh, I thought Nietzsche was into that too. Didn't Nietzsche talk about Übermenschen and all this stuff into the future, and there was something beyond humanity or something like that? Maybe that was Arthur C. Clarke. I don't know.
Scholar. Yeah.
Okay. Well, today we're going to talk, and Doug is in the secret lab, and he's going to show us some stuff you can do yourself. Several people had written me and asked about how they could build labs to start experimenting with this, and there's a lot of different ways you can do this, so that you can set up an environment that you can play around with. What do you use, Russ?
We use VirtualBox at one place. Another place uses the ESXi, which you're going to get into later, and Hyper-V.
And Hyper-V, okay. I've never used Hyper-V. Do you like it?
Yeah, it's okay. One of the simulations I'm running with my students through another organization, they use Hyper-V or vTerm, and it's working out pretty well.
Okay. If you don't know, Hyper-V is Microsoft's product that they entered the market with. We'll talk about some of these things so you can get a feel for how you can set this up. I really focused heavily on stuff that's free, so that you don't have to spend a whole bunch of money to do this. And everything I'm going to show you, and everything Doug's going to show you in the secret lab is free for the most part. Read your license agreements, because you can get in trouble with that. One of the things you're going to have if you want to build a lab is you're going to have some kind of hardware. And It may just be a desktop computer or even a laptop. You can run it. So, but the bigger the hardware you have, the better off you are, because one of the problems with virtualization is that it takes a lot of memory and it takes a lot of CPU slices so that you can run more and more VMs. I just saw somebody posted on my Facebook this morning, was talking about how he has 70 VMs running in his virtual lab now. So if you have that many things, each one of them has to have RAM, each one of them has to have CPU, and all that stuff. So now virtualization software can let you share all those things. So it shares all this stuff very well, most effectively. But the problem with virtualization is that if you want a lot of things running at the same time, what happens is those things at the same time have to all be running on one box, and that can get kind of ugly. You were also talking about AWS, Russ, just a second ago.
Yeah. Well, I mean, we got free accounts at the place I used to work at for AWS because Amazon was one of our partners.
Oh, okay.
And they have a whole things that you can run through virtualization, including you can do like just workstations, domain controllers. You can do database servers and a slew of other things too.
Well, the only thing I would caution people about with AWS and Azure, which is Microsoft's realm of that, and I think Google has some stuff like that now too, is that they do charge you for this unless you happen to have a free license, which is rare, few and far between. But I mean, basically what they do is they charge you by the box, by the cycle, by the memory, and so what happens to people is it looks really cheap, and it may well be if you're a commercial enterprise, and it may well be a good solution to hardware. But as an individual, if you're trying to pay for this all yourself, be careful about how many things you spin up, because I was trying to figure out if I set up 50 VMs and they're all running at the same time, that starts to get kind of pricey. It's not really that much pricier than if you were doing that on your own hardware, but if you're not expecting it, you could get in a little bit of trouble. The first part of this then is what is called a hypervisor. And so a hypervisor is basically, I call it a meta system. And a meta system, it manages the physical world. So the hypervisor actually takes the physical environment that you have, whatever it is, whether it's at Amazon or wherever, it's all really at some point it's physical bare metal hardware. And the hypervisor acts an interface between that physical stuff and all the virtual environments that you run. And basically what that does is it fakes out the virtual environment so that they think they're real. So if you set up a fake a virtual machine, that virtual machine has to be convinced that it has a CPU and that it has RAM and that it has a NIC and all these things. And the hypervisor acts as an interface between that physical stuff and the virtual machine. And it also, typically, depending on what kind of hypervisor you have, it has a UI. So the UI is going to let you manage all your virtual machines. So that's another meta part of it. So you as the meta user can sit in the background and sort of jump in there and say, I'm going to set up VMs, I'm going to manage them, I'm going to turn them on, I'm going to turn them off, I'm going to delete them, whatever you need to do with all the VMs. And that lets you set up this huge environment in some sort of hypervisor. And there's two types of hypervisors that we really see. Type 1 hypervisors are called bare metal. And so a type 1 hypervisor, you heard Russ mention ESXi a minute ago, that's a bare metal hypervisor that you're going to install just like you would install any other operating system on a physical device. And it takes over that device, it gathers in all the resources, and it manages them just like an operating system. Type 2 hypervisors are running within another operating system. So a type 2 hypervisor is going to sit inside of Windows or Linux or something, and it's going to run there. So you could actually mention sort of three basic hypervisors that are out there as examples. VMware. So VMware ESXi is a bare metal hypervisor. So it's very expensive. It's something you have to have a license for. It's really cool. I have some licenses for it at school. I don't have licenses for it at home, so I can't use them on the show because the license would be violated. VirtualBox, which is a Type 2 hypervisor, runs in Windows or Linux or Macs or whatever you want to run it on, and it creates a hypervisor environment within another operating system. And then the other one I mentioned was Docker, which is sort of a different kind of hypervisor. Docker is a hypervisor container, and it creates containers that you can put things inside of, and the container itself then acts like a way for that thing, whatever's inside the container, to communicate with the outside world. So you can bundle up a whole bunch of stuff, put it inside of a Docker container, or Dockerize it, as they say, and then that Docker is going to actually have some stuff inside of it, and it communicates through ports into the outside world. So that's an even more contained environment there. VMware actually has a lot of different hypervisors. So they have both Type 1 and Type 2 hypervisors. So you can get VMware ESXi, which is a bare metal. You can get VMware Player, VMware Workstation, all these kind of things that are actually more like Type 2 hypervisors. Do you have anything to add? Do you have any others you want to throw in there, Russ?
No, I really like the VirtualBox. When it comes down to a classroom of 30 students, it's free, and it worked quite well for me. The ESXi, as you've said, is it can be expensive. But yeah, VirtualBox for me works quite well.
Yeah, I agree. I use VirtualBox all the time for things, but I will caution you. So read your license agreements, because as you use these things for free, if you go beyond just sort of the educational piece of it, so if you're learning, it's cool. But here's the problem: if you cross that what they call a Chinese wall between I'm learning, I'm a student, and I don't care whether you're a school student or you're just learning on your own, and you cross over into development. So if you've ever seen the show Silicon Valley. On the show Silicon Valley, the people get in all this trouble because they did one little test of their stuff on a licensed machine at a company, and all of a sudden the company's trying to like claim to it. So be really careful about reading those license agreements if you start doing development. If you're just doing learning, that's cool, but if you start slipping over, because VirtualBox is owned by Oracle, and Oracle is a giant company with lots of lawyers. And at some point, you suddenly are worth $1 million, or you invent the next Facebook on a virtual machine, and all of a sudden you've got a big problem, because Oracle's going to say, wow, we can make money off that. And I don't know what the license agreement says, so be really careful. But there's a lot of other products out there you can play around with. For Docker, for like Kubernetes is a program that is used with Docker that manages it. But you'll have to pick some kind of hypervisor so that you can do this. And then you can build out your virtual machines to build a virtual lab. Basically, what you're going to put in your virtual lab are going to be what are called targets, or I call them red boxes. So targets are sources, which are red boxes. So sources are bad guys that would be trying to penetrate. You probably will work on the red boxes. Targets, which are blue boxes, are going to be things you want to compromise, that you want to put in your virtual environment so you can play with them. And you might even want to put what I call white boxes, which are noise. So you may want to put things in there that just are valid machines that you want to play around with, because you want to see bad machines that are blue boxes. You want to see good machines, which look like things you might see in the real world. And then you have your red box that you're working on so that you can attack these things. And you may want to have multiple red boxes, because there's a lot of different things you can play around with out there. All these things can be involved in. I was going to throw the term ISO out there. You want to tell everybody what an ISO is, Russ?
I mean, ISO is essentially just a disk image, and you can run it like an entire Windows operating system with all the files could be stored on an ISO. You grab that ISO, you can use like WinISO reader or whatever and mount it as a virtual drive onto a computer that already has an operating system installed, or you can use it to boot to like a USB flash drive from a machine that has a USB port on it, if you don't want to use your host operating system.
Right, and in hypervisors, what happens is you can actually attach these ISO images as DVDs. So you can take just a file, which you can download, and take that ISO and attach it as if it were a DVD into virtual machines. And that's typically how people spin up what I call gold images. So a gold image is then a pristine install that you set up. So you download an ISO of Linux or whatever it is you're going to do, and you put that on a machine and then save it. And you don't ever work with the gold image. The gold image is just sitting there so you can make copies of it. And in some hypervisors, that's called a template. It's usually called cloning. There's all these different techniques you can use to take those gold images. And I like to have a nice clean one so I can always go back there and I can create more copies of that gold image to use in my systems. And I'll set those up, because you're going to mess with these things. And as you mess with them, you don't want to ruin them and then have to go back to the very first square and start reinstalling. So set up a gold image. You can also snapshot. So snapshotting is a hypervisor term that means you're going to literally just take a picture of that at some point. And it's really good to snapshot your machines before you do something to them. So this is a lot like a restore point in Windows. So if you're going to install a new driver, you're going to install a new piece of hardware, oftentimes you'll want to, and Windows does this automatically a lot now, so it will snapshot your Windows system right there so you can roll back and I do that a lot because I'll install something that causes blue screens or whatever, then you can go in and you can roll this back to the point before you did that, and hopefully you don't have to start over from scratch and reinstall everything. So if you're getting ready to do a big install, it's a really good idea to snapshot everything right there so you can roll back to that if it doesn't work. Like I was fooling with Kubernetes once, and it took me a lot of tries to get Kubernetes to actually work the way it was intended to because I didn't know what I was doing, and I'm bad to not read the manual. So I'm sort of the NRTFM type person that you'll want to say that to. If you're going to set up Linux Ubuntu server, for instance, you can go to Linux Ubuntu site. You can download an ISO from there, and they have all kinds of different ISOs that you can create a gold image, put that in, and then you can use that gold image to create as many clones of that as you want and have them out there running as blue boxes, red boxes, whatever you want them to do. And that's going to let you sit down and be able to have the beginnings of a lab. The second thing you need to do with this, if you're going to build a sort of pen testing type lab, is you need a virtual switch. And different hypervisors have different ways to handle this. In ESXi, for instance, you can actually create multiple virtual switches, just like they were physical things. You do not want this stuff connected to your network. You don't want it connected to your work network or anywhere else. So you want to isolate it very, very carefully, because as you install some of these very dangerous and damaging and potentially damageable things, you're going to have a lot of problems. And I know Doug is going to show you some of these things when he talks about this from the secret lab. He's not there yet, so pretty shortly we're going to cut to Doug, but not yet. So hang in there. But basically, with a virtual switch, you can plug all your boxes into that virtual switch and then use it just as if it was a real lab with a bunch of machines sitting on a table, which is the old-fashioned way to do this. But we can do it with VMware so much easier. The other thing I was going to mention is virtual routers. If you want to get really complicated, you can add virtual routers to this environment and create multiple network segments. So you can actually have and simulate attacking machines from the outside world across NAT, PAT. You can simulate stuff with security in place. You can simulate proxy servers. You can do all kinds of stuff. So you may want to get a virtual router, and you can look for free appliances. Like one of the ones I've used that's kind of slow, but it actually works pretty well, is Frisco. Have you ever used any virtual routers, Russ?
I haven't used virtual routers. No, I never need to complexify my virtual network that way. But,
well, they're pretty fun, and they actually have appliances now that you can get for hypervisors. So if you search for them, Frisco has one. ViOS is another one. There used to be one called Avaya, which I think got bought out and turned into a commercial product. And I used to use that one a lot too. But there's all kinds of free ones out there. Of course, you can always build your own too if you want to really get crazy. You can build your own router on a Linux box and use it just like a real router. Plug it into your virtual switches, and all of a sudden you got all that. At the same time, as Russ mentioned earlier, there are cloud-based options for all this stuff as well. So you can certainly jump into the cloud and use AWS. You can jump in and use Azure. If you have licenses for all this stuff or you want to pay for it, it's certainly out there, and they're very scalable. So AWS will let you scale up to any size thing that you really want to do. So basically then, you're going to need blue boxes, which are going to be things that you're going to target. So you could build a really simple blue box out of an Ubuntu server with Apache on it, and just put up a little web page, and all you're in business. Put a Windows machine if you have a license for it, or an Ubuntu machine, or some other kind of Linux on there, and use that to target that blue box that you built. Just keep it out of all your real networks, because otherwise you're going to get in a lot of trouble. The other thing you can get, and I know Doug is going to show you a couple of these, Metasploitables. If you search for Metasploitables, you will find pre-built ISO target machines that have tons and tons of vulnerabilities on them. Don't ever expose Metasploitables to the real world. You'll get in a lot of trouble. Another one that I have is Bad Store. Bad Store is a pre-built website that has products for sale and all this stuff, and you can target it. You can put it in your network, and you can pretend you can put a router in front of it and act like you're attacking a website from outside, and all that stuff's free. So you can download that, but be so careful that you don't embed this stuff. So I know we're going to cut to Doug in the secret lab, and he's going to show us an example of using VirtualBox to build some targets. So, Doug, I'm going to cut to you, who's looking up at the sky.
Thanks, Doug and Russ. Hey, I'm here in the secret lab, and we're looking at this is VirtualBox. So this is a product that I think they told you about that's made by Oracle, and it used to be an independent thing. It's pretty much open source, and I'm sure that they talked a little bit about that on the show. I wasn't watching because I was doing better things, but basically, this is a product you can get. You can put it on your local machine. This is running on my machine here on my desktop in the secret lab. And what I've got here, we're not going to run all these things. I just wanted to show you some things about hypervisor and also about how to set up a virtual lab, and show you a couple of products that you can get for free that you can play with a whole lot. So the way these hypervisors work is that you're going to have to actually get ISOs for these various products or something. And different things come in different forms. So you may get things like Metasploitable, which come in the form of pre-built appliances. So a Metasploitable is actually a virtual machine to start with. And it was actually built for VMware. So if you want to run it in VMware Player, you can, but you can convert it and you can load it into anywhere. And so by converting it for VirtualBox, we can load it up here. This type of hypervisor, which is a Type 2 hypervisor, so it's not bare metal. It runs, this one's running in Windows. You get VirtualBox for Linux. You get VirtualBox. I don't know if it runs on a Mac. Macs are kind of, they have their own thing called Fusion or something like that. But basically, what I have here so far is I have some virtual machines that I've set up. And I've got what I call a gold box here. And these gold boxes are my master copies of these pieces of equipment. And I like to have a gold because it means I got it, I set it up, and that's just my original copy of this. And I'm not going to mess with it. I'm just going to leave it set up and turned off forever. In VMware, you can turn these things into what are called templates, which are smaller versions that don't actually have hard drives associated with them. Until you actually create virtual machines from them. VirtualBox is not quite as clean as that, but it's still a very, very cool tool. And because VMware is so expensive, I like VirtualBox and I use it all the time. Now at school we have VMware, and I have licenses for it and whatever, but I can't use it for commercial purposes. So here I'm using something that I can use for this. And you can see that there are 5 virtual machines in this folder. So I created a folder called Pen Test, and I put some stuff in here. This one, I don't know why it's here, but so I call these things gold boxes that are just the original tools. I want to show you something very, very important, though, that you need to do if you're going to set these kind of things up. And all these devices, whatever they are, and I'm going to go to this one I call the blue box. So I'm sure Doug told you what he calls blue boxes. He's kind of, out there, but mostly he knows what he's talking about. He calls these things blue boxes, and I do too. And blue boxes are targets. So you'll hear them called targets, and sometimes these things are called ranges. One of the things that is absolutely critical that you not do is to install Metasploitable or bad store on your networks. Both these products represent servers that are filled with vulnerabilities and are wide open. And Metasploitable and bad store just have stacks and stacks of vulnerabilities in them. You do not want these things to be accessible by individuals on the internet because they can be used to get into your network. So don't get involved in those kind of games. One of the things you want to do the minute you set these things up is go to Settings and go to Network and change this. Now, if you just got this normally running, it would be set on NAT, which means that it acts like a network that then NATs. And if you don't know what NAT means, and it really means PAT, to be honest with you, I think, but it NATs this into your regular network through your regular NIC. So the NIC on this particular computer, the overall computer, is NATed from this tool. And that is incredibly dangerous because that might actually be accessible. Even worse would be to put Metasploitable on a VM or something that was outward facing. Then you've got real problems. Change these things over to what is called internal networks. And what that does, and I'm not going to cover how to configure all this and how to get all this stuff set up, but basically what this does is it creates a virtual switch that this is then plugged into. So that network no longer connects to the internet. It no longer connects to this computer that it's on. It no longer connects to my network here in the secret lab. And you really want that to be in case. You can create lots of these if you want to. There's all sorts of options you can set up as well to do this. You can set up MAC addresses or anything that you need to do here. But be sure that you do this particular thing to create that virtual switch. And that's going to keep these devices off of your systems. I want to show you with Bad Store as well. Again, and I don't think I actually did this one yet. Oh yeah, I did. I usually do it immediately. But again, this one's set on an internal network, so that means it's only going to be accessible in this private virtual network. It's not going to be available out in the real world. The other piece of this that I want to show you is this piece right here. In order to load these things up, you have to install some of them. Like Metasploitable 2 is an actual virtual machine from the get-go. But Bad Store is an ISO, and I know that I saw the show notes. I know Doug was going to talk about what an ISO is. You can download these ISOs, and they're just essentially disk images. And you can burn this onto a DVD if you want to, but you don't need to here. We're going to just put it on as a virtual DVD. So I click this link right here and tell it I want to connect to some ISO file, and it treats that as if it was a DVD in a drive on this virtual machine. Once you've done that, you may want to actually go and make a workstation. And again, depending on what kind of licenses you may have, you may or may not be able to get certain products available to you. Now, if you have access to things like Windows or whatever, you can use those as well. And all of them are set up exactly the same way. I have one that I use a lot called Mint, and you see this Mint Gold. Again, it's the gold box. So I installed it. The way you do this is you just clone it. And so if I clone this and I call this, we'll call it Bad Guy Station. Or actually, I was calling them red boxes, right? So I'll call it red box, and I still like to tell myself what this actually is. And you can actually do a full clone of this. And what it's going to do is it's going to jump in, it's going to create a clone, and you see it down here. So you don't really want to use your gold boxes because they're your snapshot baselines. Now, you can create snapshots and things like that on the fly of these boxes as well, so you can make copies of them. But all these devices are then running inside of this virtual box environment. But remember, you have to go in and change the network settings of this, and this one's actually went ahead and grabbed internal network as well. So if it's not on internal network, you're going to need to set it up such that it is, and you're going to have to assign IP addresses such that they all can talk to each other. But essentially at that point, this box, and this box are all plugged into the same virtual switch, which means that if you're running Metasploitable and you're running Bad Store, you can jump on this Red Hat Mint or this red box named Mint, and you can install hacking tools. You can install vulnerability scanners. You can install Metasploit. You can install Splunk. You can install NetSparker. You can install anything you have a license for. You can Nmap, on and on and on. Put all those things on your workstation here and use them then to learn from attacking these known quantities. And if you want to create 5 or 6 of these Metasploitables, hey, just clone some more of them. And I'm going to reinitialize the Macs so that I got different ones. I'm going to call this BB1 clone. I'm going to call it BB2. And if I do this, what's going to happen is, and this one will take longer because it actually has a full-size hard drive associated with it already. These aren't set up yet. But basically then I've got multiple Metasploitables that I could use out there in my little virtual network, and I can attack those things. Now, if you want to just go at it cold, which is a great idea, you start installing tools on Redbox. And remember, you can always jump on these boxes and you can change where they're connected. So if you're Redbox, you want to connect to the internet for a while and download some tools, be careful, but you can switch it back to NAT, and then NAT's going to let it communicate with the computer that it's setting on instead of doing that. There's a lot of other ways you can do that in this tool. These hypervisors have all sorts of fancy tricks associated with them that would let you actually just copy files over. One of my favorite tricks that you can do, if I'm going to look at the settings again, under USB, you can actually install a USB controller hub on here. So just by telling it I want a USB controller, a USB 2, USB 3, whatever you want, you can then plug USB devices into your local machine and actually have them act like they were plugged into your virtual machine. And that's a really good way to copy these tools over without connecting the internet, which I just really don't advise. You can share folders. And remember, if you're building this lab for the purpose of your own experience, so just you, or you and a friend or whatever, fine. You can share these folders because these tools you're downloading or whatever from the internet are not going to get into the wrong hands. If you're sharing these folders out at work, if you're doing this at work and you start downloading hacking tools, you start downloading vulnerability scanners and other kind of tools that act like hacking tools, you might want to be careful. And likewise, sharing a folder on your local machine into this environment, if you're letting 5 students or 5 other people at work use this environment, because remember, you can create a whole bunch of these things. So I can go in here and I can say, gee, I'm going to make another one because I got 3 or 4 people who want to use this, and I'm going to call this one then, I'll call this one Redbox 2 Mint. So now I've actually got, I may have 2 or 3 users that want to work within my virtual environment. And like I say, depending on how big this machine is, and this machine's pretty big, I can set up a bunch of Metasploitables and put them in here. And I could go into different Metasploitables and give them different feature sets. Likewise, you could just build your own. I mean, there's no reason you can't just jump in there and say, I'm going to create a new Ubuntu box, and I'm going to put it up as a server, and I'm going to put Apache on it, and I'm going to build a website, and I'm just going to see what I can find out just by fooling around with it. When you do want to make new ones, you can just click New and tell it exactly what kind of virtual machine you want to build. And so like you can see, they got Windows 7 64-bit. You can, and then they've got pretty much everything you've ever heard of and stuff you've never heard of available to you to virtualize. So Linux, Solaris, all this kind of stuff is out there. Under Linux, they've got every flavor of Linux you may have heard of. And if you don't see the one you like on there, you can go down to Other, which is what I was doing because I was putting Mint on here. Mint is a variant of Gentoo, I think. I could be wrong. I use Mint a lot because it's really small for virtual machines. If you want to, but you can put full-blown machines on here. And remember, the machines you put on here are real in their own mind. This is like the Matrix, a little dated reference, but nevertheless, these machines believe themselves to be real. So as you set up a virtual lab like this, make no mistake, these machines behave and act just like the real thing. The biggest limitation you're going to have is RAM. And you can actually configure all that. So you can go in these devices and you can allocate things to them. You can set how much memory they've got. You can set the size of their hard drives. Like you can see, this has got an 8 gig hard drive that I set up. That takes up disk space on my local machine because it has to be stored somewhere. I can go in the system. I can add, I don't know why it's got a floppy disk. You see it's got 512 base memory. I could go out and increase that to some ridiculous amount of memory, like that's probably more than this system has, which is not going to be a good idea. I could lower it. I'm not going to fool with it. You can add features to this thing. You can change around how it works. You can change its processor. You can give it multi-cores. But all that stuff takes up space and capacity from your local system right here. I'm going to go back to the studio then and let Doug and Russ finish it up. So there's a quick way into the lab. Thanks, guys.
Gee, Doug, like to hear yourself talk much? Yeah, this is getting kind of narcissistic maybe. But, Russ, any other comments about that?
No, I think it was fantastic. Just one last thing I want to add is what your point earlier is very, very important. Those white boxes, man. I mean, that creating that noise takes, at least it's still a simulation, but it's a simulation of a more realistic environment. You don't want everything so controlled that you don't account for, the X factor. And I think adding those white boxes is super important and very convenient for what Doug number 2 mentioned on the screen, just by cloning. So very, very convenient, very easy to do. So don't forget to do them.
I agree, and there are tools you can get. So if you search for noise tools and things like that, you can actually get things to put in your network that generate traffic, that cause all kind of stuff. And the other thing not to forget about is while you're doing all this, you can actually build more boxes that have things on them like Wireshark. If we have a show about that, if you want to check it out. So you can actually then do multiple parts of this. So you can do forensics, you can do network forensics, you can do attacks, you can do defense, you can do all these things using this environment, and all of it running at the same time. So if you want to set up a logging tool and capture packets while you're attacking one of your blue boxes, you can actually see what that looks like. And then you can start moving into the hack naked world, which if you don't know what... Yeah, the hack naked world is like, yay. But the hack naked world, of course, being able to see what it looks like when you're attacking things. So what does it look like? What does your profile look like in that network? And that's what the term hack naked really means. But regardless of all that, I hope that you got something out of this. Keep those cards and letters coming in, telling us what you want to see, and we'll be happy to talk about it. Get out there and build your own lab. That's one of the most important things you can do, because it's going to let you learn all sorts of things at the same time. And you really can't make a huge amount of mistakes unless you fry your whole system, in which case that could be bad. But you probably won't do that. Don't do it at work. Don't do it at school, because you can get in a lot of trouble. Thanks, Russ, for joining us. Thanks, Doug in the Secret Lab, for joining us. We'll see you next week on Secure Digital Life.